Hey everybody. Let's quickly and easily figure out how a parent function has been transformed so that we can write its equation. We'll do lines first, then parabolas, then exponentials. So for the line, we'd figured out if you figure out what the slope is, you can then shift a line with that slope over and over so that it goes to the point you want, which is point slope form. So here I see for every 4 I go over, I go up by 2, which means the slope is positive 1/2. So I could imagine a line whose slope is 1/2 that goes through 0, 0. So that's y equals 1/2 x. And now what I'm going to do is imagine taking the point at 0, 0 and shifting it over 3 and up 1. Or I could shift it over 7 and up 3. And those are going to give the same equation, which I'll show you in just a second. So I'm going to shift it right by 3 and then up by 1. Let's also try out right by 7 and up by 3. If I multiply these out, let's see what I get. I get 1/2 x minus 3/2, because that's what happens when I multiply 1/2 by 3, plus an additional 1. 1 is the same thing as 2/2, so that would be minus 1/2. Okay, let's do this one. I'll have 1/2 x subtract 7/2 plus 3. 3 is the same thing as 6/2. So if I have negative 7/2 plus 6/2, that's the same thing as negative 1/2. So you can see that when I multiply them out, I end up getting the exact same equation. So either of those equations are fine. They're algebraically equivalent. They both describe the same curve. Okay, so that's for lines. Let's talk about the parabola. So one thing I can see, well, for all of these, you want to imagine what the parent function looks like. So here's y equals x squared. And you want to know a couple of reference points in the parent function. So for the parabola, we've got 0, 0, negative 1, 0, negative 1, 1, and positive 1, 1. You can imagine little slope triangles. So if I go over by 1 from the vertex, I'll go up by 1. Here you can see that from the vertex, if I go over by 1, I'm actually going up by 3. And that's a sign that my original parent function has been vertically stretched by a factor of 3. So I know I'm working with 3x squared. Okay. The vertex also isn't at 0, 0, though. It's been shifted. It looks like it's been shifted right by 1 and down by 1, 2, 3, 4. So let's write that. I've got y equals x minus 1, shifts it right by 1, and then down by 4 on the outside, and then stretched by a factor of 3. Okay, last one. Let's do the exponential. So I don't want to add the complication of having you figure out what the base of the exponential is. So I'm going to tell you it's going to be 3 to the x or 2 to the x or whatever it is. What I want you to do is, if I told you what the parent function is, be able to imagine how it's been transformed. And you do it in the same way. You need to imagine the parent function and look at some reference points. So here in the parent function, I've got 0, 1, and I'll have, let's see, 1, 3, and I'll have 2, 9. Okay, and then let's imagine some kind of slope triangle. So if I go over by 1, I'll go up by 2, because it's 1 to 3. If I go over by another 1, I'll go up by 6. Okay, let's see what we've got here. Over by 1, up by 2, over by 1, up by 6. So I see that kind of matches. That's how I can tell how it's been transformed. I can see that the point at 0, 1 got shifted to become this point here. So it must be shifted left by 2, up by 2. So I'll start with the parent function, except then I'll subtract it left by 2, and then up by 2. A lot of people are still mixing up their horizontal and their vertical transformations. And again, the way that you can tell is ask, is the thing that you're doing on the inside of the parent function? You'll know it's on the inside if you're affecting the x value before it gets converted to a y value. That's how you know it's a horizontal transformation, because affecting x values will change how far over it is, which is an x value. After it's been converted into a y value, if you're doing something to that, it's affecting how far up or down it is, and so that's got to be a vertical transformation. So outside the function is vertical, inside the function is horizontal. I hope that this will help you. Definitely want to practice it a little bit because people are really, really slow at this. But knowing these families is not only useful for these problems, it's useful for all our problems because the functions, we're using them to control things, and you got to be able to picture them in your mind.